Hello, my name is Ho Ngọc Hình, and I'm from the Department of AI Conversion, Chonnam National University. Today, I would like to talk about RASUF, a residual attention-aware method for fluorescence-free survival of Alzheimer's disease. The contents of this presentation include introduction, related study, probable methods, experiments, and conclusions. First, I would like to talk about what is Alzheimer's disease. Alzheimer's disease is the most common cause of dementia. It's caused by the formation of the abnormal deposits of protein in the brain. Two types of protein, plaques and tangles, may damage the nerve cell and cause cells to die. When a lot of cells die, they cause the brain to scream. So, they make abnormal function in the brain, such as sleeping issue, memory problem, mood disorder, and confusion. The progression of Alzheimer's disease can be visualized at the below figure. For the young people, they may have healthy brain without any problem, but when they are over 60, there's some symptom related to AD in the cognitively normal state, and a lot of symptoms may occur in the mid-cognitive impairment state before they convert totally to AD. So, in this study, our motivation is using a combination of clinical biomarkers to predict the fluorescence-free survival for CN and MCI patients. Also, we use attention module and a residual route to produce a attention-aware feature as well as to facilitate the training of neural networks. Next is a related study on survival analysis of Alzheimer's disease in 2019 and 2020. This study focused on the risk and time to AD conversion using different types of feature and survival models. The first and the last paper proposed deep learning by architectures, while the second paper applied several machine learning by survival models, such as penalized correlation, putty correlation, and random forest for survival. The third paper proposed a multi-level copyist model. Those papers use index as critical evaluation measures, and some use prior score. In this research, we proposed a deep survival model based on deep sub-architecture. This sub is a type of deep neural network including several fully connected layers, followed by global layer. Finally, it uses linear combination to estimate hazard rate function. Our global model will replace the fully connected layers with residual attention layers to better capture significant representations. The residual attention layer can be formulated as the following equation. First, we compute the attention-aware feature by multiplying function of G and attention map of submap function. Then, we sum this feature with function of G and apply ReLU activation function to generate output G hat. To optimize the model, we minimize the objective function negative log likelihood to maximize the term of suggestion between predicted hazard function and log sum of exponential of predicted hazard function. We use the dataset called IDNI, Alzheimer's disease neuroimaging initiative. The characteristics of this dataset shown in the left table. The number of patients is 1,334, with the gender ratio 739 and 595. The range is between 55 to 91.4, and the censoring rate quite high is 74%. The figure shows the distribution of censored and uncensored patients in terms of time to conversion to ID. The list of biomarkers is shown in the right table, with their missing rate. For preprocessing, we do the imputation using the MRC algorithm, normalization, and standardization. For experimental research, we evaluate using CNDAT, prior score, and mean absolute error of time to ID conversion. We compare the proper model with the copied observed and cut this model. From the table, the cut model achieved the best performance in CNDAT and prior score, but just slightly better than the proper model. In case of predicting time to ID conversion, the proposed research model achieved the best performance with the error of 600 days. Also, we use Breslow estimator to estimate the prediction of survival time for all models. In summary, we propose research model for evaluating progression-free survival in Alzheimer's disease. We utilize the benefit of attention-aware and residual block for purpose of learning significant embedding representation and avoid the overfitting problem. The experiments on the ADNI data reveal that the robot model improved prediction of time to ID conversion compared to deep search model or other. Here is a list of references in this presentation. Thank you for your listening.